Hey students, this is lesson 8.2, special right triangles. In this lesson, we're going to learn how to use the properties of 45, 45, 90 and 30, 60, 90 triangles to simplify the process of solving problems. These are really common triangles, so these problems come up quite a bit. Go ahead and do the review and I'll check back with you. All right, our first theorem, theorem 8.5, is known as the 45, 45, 90 triangle theorem. In a 45, 45, 90 triangle, both legs are congruent and the length of the hypotenuse is square root of 3 times the length of the leg. I'll prove that to you. So it's 45, 45, 90 triangle, right? So that means that if I were to complete this, I would have a square with each side s. Okay? And to find side length, so both sides are length s there. And then to find the hypotenuse, what I would do is take s squared plus s squared, and that's equal to the hypotenuse squared. And simplifying that, I would get 2s squared equals the hypotenuse squared. Taking the square root of both sides, I get the square root of 2s squared is equal to h. And then just separating this to simplify it, I get square root of 2 times square root of s squared equals h, and square root of s squared is just s. So I can just write it as s times the square root of 2 equals h. And so that's the property there. So the hypotenuse is equal to the square root of 2 times the leg. If the leg is 10, then the hypotenuse is 10 times the square root of 2. Simplifies that process, right? All right, so let's see how we can use that. Notice these are 45, 45, 90 triangles, and the hypotenuse is equal to the square root of 2 times the leg, and that's the 45, 45, 90 triangle theorem. And the hypotenuse here is h, and the leg here is 8. And if I wanted to approximate that, I could use my calculator to help me, but if I wanted the exact answer, I would just write it as 8 times the square root of 2. In the second problem here, we're going to use the same idea. The hypotenuse is equal to square root of 2 times the leg. In this case, we can substitute 5 times the square root of 2 for the hypotenuse, and x for the leg. I'm going to divide both sides by the square root of 2. And that's 1 times 5, which is just 5. And that's 1 times x. So x is equal to 5. And of course, we know since it's 45, 45, 90, it's an isosceles triangle. That side's also 5. All right, I'm going to let you try that. All right, finding the leg, again, is a 45, 45, 90, so the 45, 45, 90 triangle theorem says that the hypotenuse is equal to the square root of 2 times the leg. Our leg is x here, and our hypotenuse is 10, so 10 equals square root of 2 times x. I'm going to divide both sides by the square root of 2. And so I get 10 divided by the square root of 2 is equal to x. And this is actually not simplified, so I'm going to simplify it. And the way I'm going to simplify it is I'm going to rationalize the denominator. If I multiply the denominator by the square root of 2, it'll become a whole number, because the square root of 2 times the square root of 2 is 2. And I'm going to also multiply the numerator by that. And when I do that, I get 10 times the square root of 2 over 2. And 10 divided by 2 is 5 times the square root of 2. So my answer is A. All right, you try that. In order to change this up a little, let's change this to 20. Otherwise, we're doing the exact same problem. One thing you may have noticed is that the leg equals half the hypotenuse times the square root of 2. All right. Finding a distance, of course, a courtyard is shaped like a square with 250-foot long sides. What is the distance from one corner of the courtyard to the opposite corner? I think we're talking about the diagonal there. So what's that green line? And since it's a square, we know this is 250 and this is 250. And so we're going to use our 45, 45, 90 triangle theorem. And we know this is a 45, 45, 90 triangle because we are splitting the angles in the corner, bisecting them because this is a rhombus. So we can use the idea that the hypotenuse of a 45, 45 is equal to the square root of 2 times the leg. And of course the legs are equal to 250. And so h is equal to 2 times square root of 2 times 250. And if we just approximate that, do square root of 2 times 250, we get about 353.6 feet. All right, you try that. All right, another theorem that we can use here is the 30-60-90 triangle theorem. And the 30-60-90 triangle theorem, there's a relationship there also, and I'll show you how that works. So if we call the shortest side S of the 30-60-90, and then just think about that. If I was to put a mirror image of this, so this would be 60 here again, and this would be 30. We now have an equilateral triangle. So S is actually half of that hypotenuse. So we call that side 2S. Well, now that we have two sides, we can use Pythagorean's theorem. We can say that 2S squared, parentheses, is equal to, that's the hypotenuse, that's equal to S squared plus the long side squared. Let's just call that X for now. And so if I simplify this out, I get 4s squared, and then I'm going to subtract s squared from both sides, and that's x squared. And that's 3s squared is equal to x squared. Taking the square root of both sides, I get the square root of 3s squared is equal to x squared, or is equal to x. Sorry. And I can split that up and make it square root of 3 times square root of s squared. And of course, square root of s squared is just s. So s times square root of 3 is equal to x. And that proves that the longer leg of a 30-60-90 triangle is square root of 3 times the shorter leg. So the hypotenuse is twice the shorter leg, and the longer leg is square root of 3 times the shorter leg. Okay, let's go ahead and use that. So the long leg is equal to the square root of 3 times the shorter leg. And so we can substitute here. My long leg is 15, and the shorter leg is x. Dividing both sides by the square root of 3 gives me 15 times this, divided by the square root of 3 is equal to x. Now, that's not simplified because of the square root in the denominator. So I'm going to multiply both the numerator and the denominator by the square root of 3 to rationalize the denominator. And that gives me 15 times the square root of 3 over 3 And then I'll just simplify 15 divided by 3 at the spot. 5 times square root of 3. All right, you try that. All right, let's apply that to help us find the height of the equilateral triangle. So the height of the equilateral triangle is this distance here. And let's just call that h. And remember that an equilateral triangle is an isosceles triangle. So this is a 60 here, this is a 60 here. We just split that in half, so those are each 30. So we have a 30, 60, 90. Our side lengths are all 12 since it's equilateral. And that means that this short side is 6. And we can find the height because the long leg is equal to square root of 3 times the short leg. So h is a long leg, that's equal to square root of 3 times 6. So h is equal to 6 times square root of 3. If we wanted to approximate that, we could just multiply it out and we get about 10.4 centimeters. All right, you try that. All right, that's the end of the lesson. Go ahead and do the lesson check and we'll talk about this next time we meet in class.